Hello students, welcome for another session of our class 10th chapter 5 quadratic equations. In our previous session we have learned what is meant by quadratic equation, how can you decide a given equation is a quadratic equation, and how to represent any given situation by the help of a quadratic equation. We have learned these all topics in our previous session. Hope you all understood our previous session. In this session, we are going to learn how to find the solutions for a quadratic equation. There are three different methods to find the solution for a given quadratic equation. What are that methods and how we solve a quadratic equation using the different methods which we are going to learn in this session. Let us see the different methods what we have to find the solution for a given quadratic equation. The first method is known as factorization method. Factorization method. And we have another method that is called completing the square method. Completing the square method. Completing the square method. Otherwise, you can use a quadratic formula to find the solution of a given quadratic equation using the quadratic formula. Using the quadratic formula. Quadratic formula. It is what is meant by quadratic formula. The quadratic formula is minus b plus or minus under root of b square minus 4ac by 2a. In this quadratic formula, what is meant by b, what is meant by a, what is meant by c, these all we have to compare the given quadratic equation with the general form of the quadratic equation. General form of the quadratic equation is what? The general form. The general form. Yesterday, that means in our previous session only, we have learned what is the general form of the quadratic equation. General form of quadratic equation is what? Ax square plus bx plus c is equal to 0. Here a means what? The quotient of x square term. A is what? Coefficient. Coefficient of x square. B means what? Quotient of x. B means what? Coefficient of x term. C means what? The constant. C means what? Constant term. Constant. So, by comparing the given quadratic equation with the general form, we can identify what is the value of A, what is the value of B, what is the value of C. By substituting the A, B, C values in the quadratic formula, we can find the solutions of quadratic equation. In this quadratic formula, we have b square minus 4ac. This b square minus 4ac is called discriminant. This only tells us the nature of the roots. Roots doesn't mean by roots are nothing but the solutions of the quadratic equation. Roots are nothing but the solutions of the quadratic equation. What is meant by solution? In a given quadratic equation, whatever the variable is there, in place of the variable, which values are going to satisfy the equation, that values are called the solutions of the equation. The solutions only called the roots of the equation. So, the nature of the roots, what kind of solutions we are going to get, whether the solutions are real numbers or the solutions are same. Both the solutions are same, that means the roots. For a quadratic equation, there will be maximum two roots. Maximum two roots. The two roots may be real and distinct. The two roots may be real and distinct. Distinct means both are different. And the two roots may be same. The two roots may be real and same. Or the roots may not be real numbers. That means roots does not exist. So, even though if they exist, they are not real numbers. Real roots does not exist. That is called nature of the roots. What type of roots we are going to get for a given quadratic equation? Before finding the exact roots only, we can find the nature of the roots by the help of this b square minus 4ac. This is called the discriminant. Discriminant. So b square minus 4ac. This is called what? Discriminant. Discriminant. So if b square minus 4ac value is greater than 0, the roots are real and distinct. The roots are real and distinct. The roots are real and distinct. That means the two roots which exist for a given quadratic equation will be real numbers and both are different from each other. Otherwise, second condition, if b square minus 4ac is equal to 0, the roots are real and equal. The roots are real and equal. Both the roots are same. The roots are real and equal. The roots are real and equal. One more situation, if b square minus 4ac is less than 0, if you substitute the values of a, b, c, when you compare the given quadratic equation with the general form, you can identify what is the value of a, what is the value of b, what is the value of c. What is a? Quotient of x square term. What is b? Quotient of x term. What is c? The constant term. So by comparing with the general form of the quadratic equation, we can identify ABC values. By substituting the ABC values in this discriminant, we can find out the nature of the roots. If the value of b square minus 4ac is greater than 0, the roots are real and distinct. That means the two roots are different from each other and they are real numbers. If b square minus 4ac value is equal to 0, the roots are real and both are equal. If b square minus 4ac value is less than 0, no real roots exist. The roots does not exist. If they exist, they are not real numbers. No real roots exist. No real roots exist for the given quadratic equation. This is how, by using the quadratic formula, we can find the roots of the quadratic equation by using the quadratic formula. But to find the nature of the roots before finding the exact roots only, we can identify what is the nature of the roots for the quadratic equation by using this discriminant. b square minus 4ac value is known as discriminant. If the value of b square minus 4ac is greater than 0, roots exist, they are distinct and real roots. If the b square minus 4ac value is equal to 0, roots are real and equal. If the b square minus 4ac value is less than 0, no real roots exist. That means real roots does not exist for the given quadratic equation. This is by using the quadratic formula, we are finding the roots of the given quadratic equation. But before this, we have another two methods, that are factorization method and completing the square method. How to use the factorization method to find out a quadratic equation? Any given quadratic equation may not be solved by using the factorization method, may not be solved by using the completing square method, may not be solved by using the quadratic formula. Different quadratic equation, based on the given equation, we can choose whichever the method we are comfortable with. So let us go for the exercise 5.2 in order to find the solutions of the quadratic equation in factorization method. Let us understand how to apply the factorization method to find the solution for the given quadratic equation. See, exercise 5.2, first question is given. Find the roots of following quadratic equations by factorization method. Here there are some quadratic equations are given in the first bit. By using the factorization method, we have to find the roots of the given equation. Let us find the first one. What is given? X square minus 3x minus 10 is equal to 0. X square minus 3x minus 10 is equal to 0. For this equation, we have to find the roots by using the what is that? Factorization method. How to factorize the given quadratic equation? Very important and easy one. Just observe carefully. Here x square. What is the first term? X square. What is the quotient of x square? No number is written. That means you have to treat it as 1 is the quotient of x square. Next see the constant term. Next see the constant term. What is the constant term? Minus 10. Along with the sign you have to check. What is the constant minus 10. What is the quotient of x square? 1. We have to multiply the quotient of x square and the constant term. Quotient of x square is 1 and the constant term is minus 10. So 1 into minus 10 is minus 10. You have to keep this as a side. Okay. This minus 10 you have to factorize. This 10 you have to factorize. The factors which we are getting, taking any two factors of this product of the quotient of x square and the constant term, product of the quotient of x square and the constant term, whatever the value you are going to get, here we got quotient of x square is 1 and the constant term is minus 10. The product of those two terms is minus 10. This number, forget about this sign, let us discuss about the sign later. That number 10 will have factors. Let us write all the factors of 10, and otherwise we will just factorize that number 10. Choose any two factors so that by adding those two factors or by subtracting those two factors from one another, that means the sum of the two factors must give the quotient of x term. The quotient of x term. This product is what? The quotient of x square term and the constant term. The product we have to factorize. When you factorize, you will be getting the factors. Choose any two factors. The two factors whose sum or the difference must be the quotient of x term. The quotient of x term. Like how to choose the factors of the product. Here we got the 10 as a product. If you factorize this 10, 2 5s are 10, 2 5s are 10, 5 2s are 10. That means 10 you can write as 2 into 5, that's all. That means but two factors 2 and 5 whose sum or the difference must be the quotient of x term. What is the quotient of x term here? Minus 3 is there, along with the sign you have to check. Now we have product actually minus 10. So minus 10 means it may be minus 2 into 5 or 2 into minus 5. Both are same. You can write it as minus 2 into 5 or you can write it as minus 5 into 2. Both are minus 10 only. But which combination you have to choose? Which pair you have to choose so that the difference or the sum must be equal to the quotient of x term. What is the quotient of x term here? Minus 3. Quotient of x term is minus 3. So which pair I have to choose? 2 and minus 5. Minus 2 and 5. 5 minus 2 will be plus 3. But minus 5 plus 2 will be minus 3. We need to get minus 3. Why? Because minus 3 is the actual quotient of x. So we have to write here x square, the first term as it is. But the quotient of x is what? Minus 3. This minus 3x, how can you represent? Minus 5 plus 2. So I am writing this minus 3 only as minus 5x plus 2x. Minus 5x and plus 2x, again I will get as minus 3x only. The last term as it is minus 10. These are works you have to do in a rough space. First thing what you need to do? First, check what is the quotient of x square term. The quotient of x square term and the constant term along with the signs you have to multiply. Whatever the product you will get, that product again you factorize. Choose any two factors so that their sum or the difference must be equal to the quotient of x term. Then you can write the middle term, that quotient of x term as a sum or difference of any two factors of the product of x square term and the constant term. Here the product of x square term, x square quotient and the constant term we got it as minus 10. So the factors of minus 10 are minus 2, 5 or minus 5 or 2. So both when you take this two combination, which combination is worked out for us to get minus 3? Here minus 5 plus 2 will be minus 3, minus 5 into 2 is minus 10. So this combination, this pair is working out for us. So I took this pair minus 5x plus 2x, which will give us minus 3x, remaining the first term and the last term as it is. So now in this total expression, here x square minus 5x plus 2x minus 10. As you can see, the first x square term is as it is, the minus 10 is as it is. First term and last term I am writing as it is. Only the middle term and writing this as sum of two other terms that are what? Minus 5x plus 2x. Minus 5x plus 2x is minus 3x. In that way, we have to write the given equation as the combination of two factors of this product, which will give us the quotient of the x term. Now in this all, we have to take common. In this first two terms, I am taking x as common. So from that x square, one x is taken outside, one more x will be remaining. Minus, in this term, x is taken out, 5 will be remaining. Again in the next two terms, again, whatever the chance is there for taking common, that number you have to check as common. So I am taking 2 as common in this. So when I take 2 as common, x will be remaining. Plus 2 into x, again 2x. Again, here I should get minus. So minus, plus into minus, minus. Now 2 is gone out. 2 5s are 10. 2 5s are 10. Like that you have to take common from the given terms. Now this is equal to 0. See, always when you factorize, these two terms will be same. Whatever the term you are getting in this, the same thing will be in the other one also. When you are taking the common things, you have to choose the common what you are taking, so that the two terms of this bracket should be same always. If not, you have to recheck the previous step. Wherever you committed the mistake, you have to correct it. Always you will be getting the same things, these two. So here whatever the same things are there, you take that as common. Now x minus 5 has gone from this. What is remaining? X only. From this one, x minus 5 is taken out. What is remaining? Plus 2 is equal to 0. What is this? The product of these two terms is equal to 0. When it is possible, product of any two terms is equal to 0 means either one of them should be equal to 0 or both should be equal to 0. That means either x minus 5 is equal to 0 or x plus 2 is equal to 0. X minus 5 is equal to 0 or x plus 2 is equal to 0. Why? Because the product of these two things is equal to 0. When you get 0, when you multiply a term with 0, then only you get 0. That means either this should be equal to 0 or this should be equal to 0 or both should be equal to 0. Then only you will get the product is equal to 0. So x minus 5 is equal to 0. When minus 5 is transformed that side, it will become plus 5. And again here x plus 2 is equal to 0. When you transpose the plus 2 goes that side, it will become minus 2. That means x value is either 5 or minus 2. That means these two numbers will satisfy this equation. In this quadratic equation, in place of x, if you substitute 5, you will be getting 0. Otherwise, if you substitute minus 2 also, you will be getting 0. That means these two numbers are called the roots of the given quadratic equation. Therefore, the roots are 5 and minus 2. Any quadratic equation will be having compulsory the two roots at most. The two roots may be two different numbers or two same numbers. By factorization method, you will be getting compulsory two roots. These are the roots of the given quadratic equation. This work you need to do in a separate space to how to split the middle term in order to get exactly the quotient of x term along with the sign. How you decide the factors? You have to multiply the x square quotient and the constant term. The product you have to factorize and you have to choose a pair of factors so that the combination of them, that this combination means sum of those two or the difference of those two, must be the quotient of x term. That is the exact method of finding the roots of quadratic equation by using factorization method. Very easy and important method. Hope you understood this. One more problem we will choose from this bit in order to understand even more better. Let us see the next problem of this bit. Second one, 2x square plus x minus 6 is equal to 0. Same as the previous one, what I said. First look at the quotient of x square term. What is the quotient of x square term here? 2. So write that quotient of x square term first. Multiply this with the constant term along with the sign. What is the constant term? Minus 6. So multiply this. Minus 6. 2 into minus 6, it is minus 12. Just factorize the 12. Factorize the 12. What will be the factors of the 12? 2 6 are 12. And again 2 3s are also 6. So what you got to factor as 2 into 3. These are the prime factors. Now choose the combination of two numbers which sum or the difference must be equal to the quotient of x term. What is the quotient of x term here? 1. How can you get that one? This you can write it as 2 into 2 4 and 4 into 3, that is also 12. So the difference of 4 and 3 is 1. But that 1 is positive or negative? Just got the quotient of x. Quotient of x is what? Plus 1. That means we need to get plus 1 as the difference of these two factors. The product of the x square quotient and the constant term, what we have got? Minus 12. So that minus 12 factors, how can you write? Minus 4 into 3 you can write. Otherwise 4 into minus 3 also you can write. So both will be giving us minus 12. So that minus 12 can be written as, the product of 4 into minus 3 or minus 4 into 3. Both will give us the product as minus 12. But which combination, which pair you have to choose in order to get the quotient of x? The quotient of x is positive 1, plus 1. How to get the plus 1? 4 minus 3 will give us plus 1. So we have to use this pair in order to get the quotient of x along with the correct sign which we need as positive 1. So see, the first term we have to write as it is 2x square. The last term also I have to write as it is minus 6. The middle term is what? Plus 1x. How can you get plus 1x? By writing 4x plus 4x minus 3x plus 4x minus 3x. See, plus 4x minus 3x will be equal to plus 1x only. See, I am writing the first term as it is and the last term also as it is. Only the middle term we are writing as a sum of two different terms. So what are that? Plus 4x minus 3x. Plus 4x minus 3x is equal to plus 1x, which is our middle term. See, plus 4 into minus 3, that is minus 12, which is the product of the quotient of x square and the constant term. Both combinations should be worked out. Here we have split the first term, that means we are writing the middle term as the sum of or the difference of any two different terms. First term as it is, last term as it is. Only the second term, the middle term only, we are splitting as 4x minus 3x. Now, same like the previous one, we have to choose common from the first two terms and common from the next two terms. So first two terms are what? 2x square plus 4x. In this, what is the common thing? 2 is common there, x also common there. So you can take 2x as common. When you take 2x as common from this term, what is remaining? 1 more x is remaining. 2x into x square plus. From this 4x, if you take 2x as common, what will be remaining? 2. 2x into 2, 4x. So first two terms are completed. Next, I already told you in the previous question, always whatever you got in the first bracket, the same thing you should get in the second bracket. In order to get that, what should be taken common? Inside the bracket you should get plus and x and 2. So here 3 is there, here 6 is there. That means you can take 2 common from this. That means 3 if you take common, 3 1 the 3 2s are. You will be getting that. Again, you have to get plus also. So that you have to take here minus 3 as common. If you take minus 3 as common, first what you get? X. See, minus 3 into x, minus 3x. Again you have to get minus only. That means if you write plus here, minus into plus you will be getting minus. To get 6, what you need to write? 2. Minus 3 into plus 2 is minus 6. So see, first bracket also x plus 2, second bracket also x plus 2. If you get like this, our step is right. Otherwise, you have to check the previous step, whatever the mistake you did, you have to correct it. Always you will be getting same like this. So whatever the things you are getting same, that only you have to take it as common again. Now x plus 2 is taken outside. Remaining is what? Only 2x will be remaining. From this also x plus 2 is taken outside. What is remaining? Minus 3. So this is equal to 0. Again same, product of the two terms is equal to 0 means either of them should be equal to 0 or both should be equal to 0. So x plus 2 is equal to 0 or 2x minus 3 is equal to 0. Now x plus 2 is equal to 0, that means plus 2 when you transpose that side will become minus 2. Or here 2x minus 3 is equal to 0 means when you transpose that minus 3 that side it will become plus 3. Then x is equal to 3. Here in between x and 2 there is multiplication. When you transpose this 2 that side it will become in the denominator. That means x is equal to minus 2, x is equal to 3 by 2. Both will be satisfied this equation. In place of x, if you substitute minus 2, it will be equal to 0. Otherwise, if you substitute 3 by 2 also, it will be equal to 0. That means these are the two solutions. You can call these two are the roots of the given quadratic equation. Therefore, the roots are minus 2 and 3 by 2. There are the two roots which we have got by using the factorization method. Here only one important thing what to do. First thing, you have to multiply the quotient of x square with the constant term. The product you have to factorize. Choose any two factors with combination of those two. That means sum of those two or the difference of those two must be equal to the x quotient. So that the pair you have to choose. The first term you write as this, the last term you write as this, the middle term only you have to write as sum of two different terms or the difference of two different terms, so that you can take common. The two brackets which you are getting both should be same, so that you will take the as common, the remaining you will be getting in other term. So then you transpose the constant terms to other side in order to get the x value. That are the roots of the quadratic equation. Hope you all understood this method. There are some more problems in the same way. If you practice that by looking at this video, hope you will be understanding even more clearly. Thank you very much. In this session, we have learned the factorization method. Again, some more problems are there in the exercise 5.2. When we meet in the next session, we will be continuing the second part of this 5.2 exercise. Thank you very much.